Now in this video we will see the problems on right circular cylinder, and here the guiding curve is a circle, so we are talking about right circular cylinder. Now first we have this result which states that the equation of the right circular cylinder with the axis which is given by this equations and radius of the guiding curve lambda. If lambda is the radius of the circle, guiding curve here is circle, so for that guiding circle we have lambda to be the radius, means then we are going to have the equation of the cylinder to be like this. So for this we shall consider any point on the cylinder to be p of x1, y1, z1, and the axis is the line what is given that we are taking. Now it passes through the point q of alpha, beta, gamma, and the direction cosines of the axis are, direction ratios are given, so direction cosines that we are writing. Now the axis meet the normal section of the cylinder through P at M. So we consider the normal section. See, when we consider the right circular cylinder, any normal section will only be a circle. So we shall take M to be the center of that circle. Now from this right angle triangle, where this point Q of alpha, beta, gamma is any point on the axis of the cylinder. So P is on the cylinder and this is on the axis of the cylinder, and M is center of the circle. So from this right angle triangle we have PQ square to be QM square plus MP square. Now of which we have our PQ square being obtained in this way. We know the coordinates of P, we know the coordinates of Q, so use distance formula to get your PQ. So that is what is written here. And MP being the radius of the cylinder which is given as lambda, so MP is also known. So now we are bothered about only this QM. So how to obtain that QM? So for that we consider this diagram. In this right angle triangle we are taking this angle to be theta, that is angle between QP and QM to be theta. So once we take that our QM, that is what we need, so our QM will be QP cos theta. Our QM will be QP cos theta. Theta is the angle between these two. Now to obtain cos theta we must know the DCs of QP and QM. To obtain cos theta we must know the DCs of this and this. Now DRs of QP, having got the points P and Q, we can write out the direction ratios of QP, which is x1 minus alpha, y1 minus beta, z1 minus gamma. So that we have written. And direction ratios of QM, so that is given LMN. So that is written here. Now DCs of QP will be x1 minus alpha divided by square root of x1 minus alpha the whole square plus y1 minus beta the whole square plus z1 minus gamma the whole square, which is nothing but PQ or QP. So we have x1 minus alpha by QP, comma y1 minus beta by QP and z1 minus gamma by QP. Now DCs of QM, when we consider DCs of QM, DRs are known, so we can write out DCs of QM. So having got the DCs of QP and QM, cos theta can be easily obtained. So that is x1 minus alpha by QP into L by root of L square plus M square plus N square. And the same way you have to consider the product of these two plus the product of these two. So that is what is written here. Now QM is QP into the whole lot. So one QP being common can be cancelled with this, so that your QM will be x1 minus alpha into L by square root of L square plus M square plus N square. And the same way here y1 minus beta m divided by this and this one. So this being common, we are having this. So qm we have got, and that is what is written here. So we know qm, what is qm, what is pq, and what is mp. So you just substitute them, and then this is any point on the cylinder, therefore the locus of x1, y1, z1 will give this. So any problem in which the axis, equations of the axis is given and the radius of that circle is given, then we can, by this formula, we can easily write out the equation of the right circular cylinder. Now we have an example in this. Find the equation of a right circular cylinder whose axis is x-axis and radius is r. We know the equation of x-axis is given by x by 1, y by 0, z by 0. X by 1 equal to y by 0 equal to z by 0. And radius is given to be r. Now we know, just now we had the result in which we had the equation of the right circular cylinder to be this. So we will make use of this. In the place of x1, y1, z1, you have 0, 0, 0. So that is what is written here. And lmn is given by 1, 0, 0. So 1, 0, 0. So here in the denominator, 1 square, 0 square plus 0 square. So we have this. And this on simplification will give you this. Cancelling on x square, we have y square plus z square equal to r square. So when you have x-axis, here x is missing. Y square plus z square equal to r square. Now in the same way, if we consider y-axis, first we had x-axis. Now if we consider y-axis, then in that case same procedure. But here you have y square, cancelling that. If it is y-axis, y will be missing here. X square plus z square equal to r square. And in the same way for z-axis, where you have z missing. So x means x-axis means x will be missing. Y-axis means y will be missing. Z-axis means z will be missing. So x square plus y square is equal to r square here. Same procedure for z-axis. The equation is x by 0, y by 0, z by 1. So we have, using this formula, we can easily obtain the equation of the cylinder. Now this problem in which we have the axis being given by this, in order to have it in this form, what we are going to do, we are going to divide throughout by 2. So that this equation will now reduce to this form: x minus 0 by 2, y minus 0 by 1, z minus 0 by minus 2, and radius is given as 2. So make use of this formula and substituting in the place of x1, y1, z1, 0, 0, 0. In the place of lmn we have 2, 1 minus 2. On simplification we have this. Now fifth one, here not directly the axis equation is given, but the axis passed through this point and it has got direction cosines proportional to. So we make use of the information given and obtain the equation of the axis. Radius is given as 3. Make use of this formula and you arrive at the equation of the right circular cylinder, which can further be simplified. Now this example, we had already. So again we shall have the same example. Find the equation of the right circular cylinder whose axis is given. Radius is not given explicitly, but instead we are given that the cylinder passes through the point 0, 0, 3. Now for this we shall consider this diagram. So in this figure, axis QM of the cylinder is. So this is your QM, and any point we shall take it as say some A on the cylinder, which is given as 0, 0, 3. So we have this. Now if we know, see, axis of the equations of the axis of the cylinder known. So if we know the radius then we can make use of this formula to obtain the equation. Now how to obtain this radius AM? So this radius AM is nothing but AQ square minus QM square. From the Pythagoras theorem, from the right angle triangle, AM is nothing but square root of AQ square minus QM square. Now how to find AQ? AQ using distance formula, because we know the coordinates of this point, and this is a point 210 on the axis that is given, so Q is known. So use distance formula to get AQ. So when we use distance formula, we have 2 minus 0 the whole square, that is 4. 1 minus 0 the whole square, that's 1. So 4 plus 1, 5. And then 0 minus 3 the whole square, that is 9. So we have square root of 14 to be the distance between this A and Q. Now we are going to find what is this QM. Now from this right angle triangle, it can be easily seen that this QM is nothing but AQ cos theta. QM is nothing but AQ cos theta. Now what is cos theta? Cos theta, if we know theta to be the angle between these two, if the drs are known, cos theta can be easily written. So the drs of AQ, you just subtract. So 2 minus 0, that is 2. 1 minus 0, that is 1. And 0 minus 3, so minus 3. So 2, 1, minus 3. These are the drs of AQ. And for QM, theta is the angle between these two. For QM, we are given 2, 1, 3 to be drs. So from these two, cos theta can be obtained. So it is 2 into 2 plus 1 into 1 plus 3 into minus 3 divided by square root of 4 plus 1 plus 9. 4 plus 1 plus 9. So that is 14, square root of 14, and if you simplify the numerator, it is minus 4 by this. Now cos theta is given by this. Already we know what is AQ, that is root 14. So AQ cos theta will be minus 4 by square root of 14. So QM is minus 4 by square root of 14. Now AQ we know already, QM we know from this. So AQ square minus QM square gives 14 minus 16 by 14, which is when we take LCM gives us this, and this on simplification gives you square root of 90 by 7. So the radius is known, equation of the axis given. So we make use of this formula so that you get the equation of the right circular cylinder to be this. And this on simplification gives you this equation. So now we have this problem. In this explicitly again the equation of the axis is not given, radius is also not given. So this problem, which comes under right circular cylinder, is different from the rest of the problems. So we'll have to obtain the radius of the cylinder and the equation of the axis. So if only we know these two, we can easily get the equation of the right circular cylinder using the formula. So how to obtain the equation of the axis and how to obtain its radius of the circle, radius of the cylinder. Now it is seen that the guiding curve is the intersection of the plane passing through A of A00, 0A0, 00A, and the sphere passing through the points A, B, C and the origin. This type of problem already in spheres we have already come across, and even in the case of cone we had this type of problem. Instead of A, we would have had B and C. This is A, B, C, like that. Now the equation, so this is the result that we are borrowing from the sphere section. the equation of the sphere OABC is given by this x square plus y square plus z square minus ax minus ay minus az equal to 0. This is obtained by just considering the general form. So if we consider the general form of equation of sphere, we know that it is given by x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So in this case, if we because it passes through origin, this d will not be there, and then because it passes through a0 0, we get by replacing x square by a square, we have this to be 2ua equal to 0. So from which u is equal to we can cancel one a, so we have u is equal to minus a by 2. So substituting that over here, you will get minus ax. In the same way, minus ay minus az. So this is the equation of the sphere. This is the equation of the sphere which pass through O, A, B and C. Now the center of this is very obvious, a by 2, a by 2, a by 2, and its radius square root of a square by 4 plus a square by 4 plus a square by 4 minus 0. So that on simplification gives you this. So for the sphere, we have got for the sphere, this is the sphere that we consider. So for the entire sphere, we have got the center and the radius. So radius is a root 3 by 2 and the center is given by this. Now the equation of the plane ABC, when we consider the equation of the plane ABC, that's given by x plus y plus z equal to a. Now the axis of the cylinder is perpendicular to this plane and passes through the center of the circle center of the circle ABC. So we consider the axis. See, we know the center of the sphere to be a by 2, a by 2, a by 2. So point is known, and the equation of this plane we have, from the equation we have 1 by a, 1 by a, 1 by a. That is rewriting this as x by a plus y by a plus z by a equal to 1. We can easily see that this direction ratios of the normal are given by 1 by a, 1 by a, 1 by a. So we know a point is known, dr's are known, then we can write out what is this CF. The equations of CF can be easily written. So the equations of CF is given by this. And let us take that as say some r. Now any point on CF, from here we have this. Just by cross multiplying, this is what you get, and of course this point lies on the plane, so from which we have this relation r by a is equal to a by 3 plus a square by 2. Now using this in 1, we get f to b. So 1 is this, so you have replacing r by a by a by 3 minus a by 2, and then simplifying that a by 2 will get cancelled, giving just a by 3. So this is these are the coordinates of f. Now as C is this point which is known to us already, C is the center of the sphere and f is the foot of the perpendicular. F is the foot of the perpendicular from C to x plus y plus z equal to a. F is the foot of the perpendicular from the center of the sphere to the plane. So we know what C is, and what is that F? What is that F? So having got this, by distance formula we can obtain CF, which we can find as a by 2 into root 3. Now we have FP to be CP square minus CF square. So CP square minus CF square, CP square minus CF square is FP square. So using that we get Fp. This on simplification Cp square known. Using Cp square we have it as 3a square by 4 Cp square, and Cf square is minus a square by 12. So this on simplification gives you Fp to be square root of 2 by 3 into a. Now having got the radius and the equation of the axis, x minus a by 3 by 1 equal to y minus a by 3 by 1 equal to z minus a by 3 by 1 and radius a, and use this formula. So we get this, and this on simplification will give you this. Now we also note from this the natural question will be, you are having got a by 3, you are substituting, why not retaining the one what was given in equation 1 the same? Yes, even that can be considered, but when we simplify this, final answer will be the same for both. So now we will pass on to the enveloping equation of the enveloping cylinder. The locus of tangent lines drawn to a given sphere parallel to a given line is called the enveloping cylinder of the sphere. Now we will derive the equation to find to find the equation of the enveloping cylinder. We proceed in this way. The equation of the enveloping cylinder whose generators touch the sphere and are parallel to this is given by. Now for the proof we shall consider x1, y1, z1 to be any point on the enveloping cylinder. Then the equation of the generator passing through x1, y1, z1 and parallel to x by l equal to y by m equal to z by n to be x minus x1 by l equal to y minus y1 by m equal to z minus z1 by n, and let us take that as say some r. Now the coordinates of any point on this line, very naturally it is x1 plus lr, y1 plus mr, z1 plus nr. Now this one touches 1. So we can replace this equation. X is replaced by x1 plus r the whole square, so and so on. So we have see actually this tangent, the line which touches this, if it is a cone, okay, it will intersect the sphere in 2 points, but once it is a tangent we have to have the roots of the quadratic equation coinciding. So that expression is further simplified like this. This equation must have equal roots and therefore discriminant must be 0. So 4 and that is b square should be equal to 4ac. A is this, c is this, b square, that b is given by this. So therefore the locus of x1, y1, z1 will be, you can cancel 1, 4 and then you have this. So that is the equation of the enveloping cylinder. Now the enveloping cylinder of the sphere, in this and the previous one we had the enveloping cylinder of the sphere with this x minus a the whole square was not there, just x square plus y square plus z square, only that was there. But here we are having these terms also with tangents parallel to this. So in this case procedure is the same, but the equation differs here. L into x we had, here x minus a, m into just y, here m into y minus b, and n into z minus c the whole square, and x is replaced by x minus a, y is replaced by y minus b, and z is replaced by z minus c, and this one is retained as such. So depending on the problem asked, whether we have to use the first one, this one, or this one, we'll have to decide and do. Now as an example, find the equation of the enveloping cylinder of the sphere whose generators are parallel to the line. Some line is given. Now we know that the equation of the enveloping cylinder whose generators touch the sphere, this, and are parallel to this is given by this equation. Now just compare this LMN here 1 minus 2 3. So 1 minus 2 3, and yeah, this A we have as 5. A square is 25, so A is 5. So now substituting the values of LMN and A in this equation, we get the equation of the enveloping cylinder. Now in this, we have the previous one. See, we have to use the second one. We have to make use of the second one. So this equation we need to use because it is not the sphere with the center as the origin, but the center is something else. So we have to make use of that. A is x minus a the whole square, y minus b the whole square, z minus c the whole square. If this one remains the same, only the changes over here only. So we have to consider rewriting this in this form. Rewriting this equation in this form, we will have a to be 1, b to be minus 2, c to be 0, and r to be square root of 6, and LMN being 1 1 1. So just to substitute, and on simplification we arrive at this. Thank you.